Okay, so the first thing we already did it. This is the JFET. Okay, and the way to build it with JFET, they can be using fixed bias, cell bias, and voltage divider bias. Okay, so to your side, when you're looking into the circuitry, you have to know what the DC bias. Okay, so we're looking into the circuitry here. This is the gate. This is let's see, the source, and this is the drain. Okay, make sure you know. That is the gate. That is the source. And this is the gate. Okay? We don't have any DC voltage at the gate. No DC voltage here. So they will be fixed. No, not fixed bias. They will be cell bias. Okay. For the cell bias, if you want to solve the problem, they have to give you the graphic in order to do calculations. Okay? However, like we already talking, if you be going up to the engineering, then you can using graphic. Okay? However, for electronic technician, they don't want to using graphic. Okay. If they're not using graphic, then they have to be given to you something else. For example, for this circuitry, they given to you ID equal 1.96 milliampere. That means they given you the current ID. Okay, make sure you know in the JFET on the time ID equal IF. Okay? So, now, they say this is a common source amplifier. Okay? They given to you IDSS equal 12 milliamp, VGS off equal minus 3 volts, and ID. Remember, this IDQ, not IDSS, equal 1.96. They want to solve for VGS. Okay? Now, VGS basically you will be seeing V D at V equal VG minus VF and VG equal 0, no battery connection, 0 equal VF, okay? And you know equal minus VF and VF equal ID times RF. Okay, so that's why you already know ID, IF. IF you already know. That's why you're able to calculate easy VGF. Okay, now this is the modified. Okay, so VGF equal I minus ID times RF, that equal minus 1.78 volt. Then they want VD, okay, and VD equal VDD minus ID times RD. That's given to you, okay? 5.53 volt, okay? VF, that means VF easy to calculate already. And calculate the GM0. So you go to the GM0 here. Just a formula, okay? Equal to time IDFF divide VGF of absolute value. And that's why you can get 8 millisieverts. And they want calculate the GM. Then you using this formula. Okay? You will get the value is 3.25 millisieverts. So basically, if you can memorize the formula, that's good. However, we don't care. Normally, they asking for calculation. They will be support for formula. Okay? So now, they say, since the circuit is cell bias, no graphic, graph given. Therefore, they given to you ID Q equal 1.96 milliamp. Okay. Okay, finally, find the AC output voltage. Okay. They given you two pictures to make it more clear. When you try to working on AC, then on off the DC power supply must be grounded. That will be ground. Okay? And in here, they bring it up. Okay? If you get the load, okay, so the output impedance to the amplifier, they will be equal RD parallel RL. Okay? And also, you get the C1, C2, C3. And we already know C1 DC blocking. That means they allow AC to go to the gate, not DC. C2, okay, also the same DC blocking AC coupling. What that mean? That means at the draining here, okay, you get the sine wave coming up at the drain, and also you get the VD DC. That means you get a true voltage. So when they go into the load here, it's a speaker. Speaker cannot allow DC coming out. So that's why you must get DC3. Okay? And the same thing, C3 here. It's a bypass. Okay? Same thing in the bipolar. Okay? Now, what input resistance is seen by the signal source? Okay? In this figure here. IDS equal 30 milliamp and VGS equal 10 volt. Okay? So, that means if this is your signal coming in, you're looking into the amplifier. What input resistance, okay, we'll see by this. Let's see. They do calculation here. The input resistance at the gate of the JFET RE, okay, equal VGS divide IGSF. That means you get 333 mega ohm. So, the input resistance seen by signal source RE equal RG parallel with RE. Okay? So that means you have to do a calculation for input resistance at the gate itself. Okay, that's what they call RE. And if they're looking into the circuitry here, also you get another RG. Okay, so RE and RG parallel. That input resistance. And on of the calculation, the calculation here, okay, we given you the formula and the answer here. Let's see. You can try to calculate it, okay? If you get a problem, let me know. Now, let's see. What input resistance is seen by signal source? Okay, so you get IGSS, okay, equal 30 nanoamp. SVGS equal 10 volt. Input resistance at the gate of JFET equal RE of the gate equal VGS divide IGSS. Input resistance seen by signal source GE equal RG parallel R in gate. And finally, input resistance equal 9.7 mega ohm. Okay? Remember, if you're looking into here, you can see you get a 1 RG. However, you have to calculate the resistance of the FET, okay? And we're already telling you, okay? R in gate, this is a formula. You have to remember. So they get a resistance here to the round. Finally, if you're looking from here, you get two resistance in parallel. Now, the MOSFET amplified operation. You know that the MOSFET, the particular, the MOSFET yield in amplitude of this figure here. They get IDSS of 200 milliamp and GM 200 millisiemens. They determine both the DC drain voltage and AC output voltage. Okay? They given to you VE equal 500 millivolt. Okay? Now we see, since the amplitude is zero bias, okay, that means they not given to you, okay, ID. IDSS equal ID, 200 milliamp. And therefore you can calculate the VD. VD equal VDD minus ID times RD. That given you 8.4 volt. And then, okay, you understand when they say D, small d, that means output impedance. Okay, D. Basically, they're talking about output impedance. So they will be equal R D parallel RL. So you see, this is AC, this DC will be rounded. So you get R big D and also RL. They will be parallel. Okay? So that will be output impedance. Normally, depend on different textbook. Sometimes they using R small d. That means output impedance. Okay? When they using small d, that means output impedance. Okay? So you calculate the get 32.9. AC output voltage AV out equal, okay, GM time RD. That means the gate time V in. You get 3.29 volt. Okay. Let's see. Now, the MOSFET amplifier. Okay. The MOSFET amplifier circuit. So, at and IDSS 200 milliamp and GM 200 millisieverts. They want to know DC drain voltage VD. Okay, you know this will be D. This is the gate, and that will be the source. Okay, now let's see. Since the amplifier is zero bias, therefore ID equal ID at 200 milliamp. So you get the ID, you can calculate the VD. VD equal VDD minus ID time RD. Okay, get 8.4 volt. Output impedance G out RD parallel RL. And you calculate the V out, take the gain time V in. This is the gain. You get 3.29. Okay? Let's see. A common source amplified in a MOSFET. Okay, that will be a MOSFET. A cell. Okay, 5 VGS, okay, ID VDS, and the AC output voltage. Assume that for this particular device, ID on equal 200 milliamp at VGS equal 4 volt and VGS equal 2 volt. GM equal V in equal. Okay, and this is the solution. VGS, okay, equal. So basically, this is the voltage divider. You can calculate the VGS here. Okay, equal VDD times R2 divide R1 plus R2. Okay, that's what they given you, the formula here. For VGS equal 4 volt. And you need to calculate the K. Okay, the K will be equal ID on divide, okay, VGS minus VGS TS square. So K equal 50 milliamp per V square. Okay, ID calculate equal K times VGS minus VGS TS square. That's given to you 2.65 milliamp. And VDS, okay, equal VDD minus voltage drop across RD. You get 6.26 volts. And G out will be equal the parallel of RD and R. Okay, that given you TKO. V out, AV times V in. AV will be GM times G out, okay, times V in. That given you 1.73 VIMF. Okay, and that one, the common source amplifier using a MOSFET given the following, okay, ID on 200 milliamp at VGS 4 volt, VGS TS 2 volt, GM 23 millisiemen, and VE equal 25 milliVRMS. They want to solve for VGS ID, VDS, Vout. And basically, this is on the solution, okay? You can try again. Make sure you know how to calculate it, okay? So basically, that is cover for JFET amplifier, okay? And also D MOSFET, E MOSFET, amplifier. Okay? I hopefully you try keep go through over. Remember the way, how to calculation. Okay? How, if they given any problem, they need to given to you the formula. However, you have to know when you see which formula will be using, okay, and the unit, okay? So that will be done with the JFET, okay? So if you get through it and you get a question, will be bring it up to me, okay? So that will be completely done, okay? We'll see you in the class. Bye-bye. Thank you.